7 million years ago. Across the open woodlands of Africa, a small creature descended from the shelter of the trees and set one foot upon the earth. It could not have known that this awkward, upright stance would begin a journey longer than the whole of human memory. From that first step, hands were gradually freed, stone became a tool, fire became a refuge, and ancient human groups began to travel beyond the horizon. Tonight, we shall journey backwards through time, crossing arid valleys, primeval forests veiled in mist, grasslands stalked by predators, and caves illuminated by the earliest flames. We shall meet Lucy, Homo habilis, Homo erectus, the Neanderthals, the Denisovans, and at last Homo sapiens, the only human species still living today. Welcome to this bedtime journey through the deep past. Before we begin, you may subscribe to the channel so that you do not miss the historical and prehistoric documentaries still to come. Let your thoughts grow quiet. Allow your breathing to slow, and let the story carry you gently away from the present. If your eyes close before our journey is over, that is perfectly natural. And now, let us return to the place where Imagine Africa nearly 7 million years ago. There are no roads, no cities, and no trace of anything we would call human. Before us lie open woods, green corridors beside the rivers, and broad clearings beneath a warm, heavy sky. Morning light passes through the leaves and rests upon earth still dark from the night's rain. Primates move among the branches overhead. Below them, predators wait unseen behind the grass. This is the world before humanity. Somewhere in that changing landscape, ancient ape populations are beginning to follow a path different from the one that would lead to modern chimpanzees. They are neither human nor chimpanzee, but creatures of a distant age, when the boundaries between evolutionary branches remain as indistinct as mist upon a river. No single dawn announces the birth of the human line. Evolution works through innumerable generations, altering bones, muscles, posture, and habits by degrees too small for any individual to notice. Many changes vanish, a few endure, quietly opening possibilities that did not exist before. Africa's climate rises and falls through long cycles. Woodland, scrub, riverside forest, and open ground form a shifting mosaic. Water changes with the seasons, and feeding places grow farther apart. In the trees, leaves conceal the body. On the ground, every movement may be seen. In such mixed country, an upright posture may begin to offer modest advantages. A creature can rise to look over the brush, search for a distant tree, or catch the motion of a hunter. It can balance on two legs while gathering fruit from low branches. Freeing its hands, crossing an exposed space, it may take several uncertain steps before returning to its familiar gait. We cannot witness those moments. Yet beneath ancient African soils, fragments of bone have survived long enough to preserve their faint testimony. One of the most enigmatic comes from what is now Chad, between 7 and 6 million years ago. A creature lived near lakes, open woodland, and scrub. Much later, a skull was discovered and named Sahelanthropus chadensis. Its more familiar name is Tumai. Were Tumai to appear before us, little would seem recognizably human. The face is low, the forehead retreats, and the brain case is small. Yet the opening where the spine meets the skull seems placed in a way that may have allowed the head to rest more upright. This raises the possibility that Sahelanthropus sometimes moved on 2 feet. The evidence remains too slight for certainty. Tumai may stand close to the root of the human family, or may belong to a neighboring branch that disappeared. It is therefore misleading to call this creature the first human. Better to picture a shadow at history's threshold, suggesting that nature had begun experimenting with upright posture remarkably early. One sultry afternoon, a sahelanthropus-like animal searches for food near the woodland edge. Grass stirs. The creature pauses, lifts its head, and raises its body to see farther. For a few seconds, two legs carry most of its weight. There is no ambition to become human, no destination written into the act, only the immediate necessity of surviving the day. Farther east, in the country now called Kenya, another species appears about 6 million years ago, Aurorin tuganensis. Its remains are incomplete, but surviving pieces of thigh bone suggest legs capable of bearing weight in a manner associated with bipedal movement. Aurorin is still an accomplished climber. For trees offer food, rest, and safety on the ground. However, it may hold itself more erect. Such beings inhabit two worlds, traveling through branches when feeding, descending to cross a clearing, and climbing again before darkness settles. At first, walking on two legs is likely to be slow, brief, and unstable. The body is far from the human form. But if upright movement reveals danger sooner, uses energy more efficiently, or permits an animal to carry food, even a slight advantage can matter when repeated through thousands of generations. More than 5 million years ago, Ardipithecus appears in East Africa. Ardipithecus cadaba, known from roughly 5.8 to 5.2 million years ago, offers further signs that bipedal walking is becoming established, though life in the trees has by no means been abandoned. Then, around 4.4 million years ago, another species leaves behind the celebrated skeleton called Ardi. Ardipithecus ramidus. Ardi does not live upon an empty savanna. Trees remain abundant. A grasping big toe helps on the branches, while the arms and hands reveal a life still closely tied to climbing. Yet the pelvis possesses features connected with upright posture and movement on 2 feet. Old and new structures coexist within one body. Above the ground, Ardi can cling to a branch below. The pelvis allows a measure of upright walking. The gait may be ungainly, but it reminds us that evolution does not redesign an entire creature at once. It alters a body like an ancient house, preserving useful rooms while adding new passages. Picture a morning in the open forests of ancient Ethiopia. A small group of Ardipithecus descends slowly from the higher branches. An infant holds fast to its mother while the others spread out in search of fruit, seeds, and tender leaves. This scene is a reconstruction, not a memory. Yet anatomy and environment make it plausible. Every search for food is a negotiation with distance, weather, terrain, and danger. Why then does walking on 2 legs persist? It may make travel between scattered feeding grounds more economical. It may allow an animal to see over brush, carry food or an infant, or expose less of the body to the fierce midday sun. Most likely there is no single cause. Bipedalism grows from several small benefits acting together in unstable surroundings. Evolution does not choose perfection. It retains whatever is useful enough for a creature to live and reproduce. Nor should we imagine one inspired individual standing upright and being instantly copied by the rest. Within a population, some bodies are only slightly better suited to erect posture, while others remain more dependent on climbing. At first, the differences may be invisible. Across hundreds of thousands of generations, however, they accumulate. The thigh bone changes the way weight passes into the leg. The pelvis must support both upright movement and the old demands of climbing. The spine carries the head higher, while the feet begin to perform work once shared among 4 limbs. All this happens too slowly to be felt within a lifetime. Each creature is born, feeds, mates, raises offspring, and dies in a body nearly like that of its parents. Only when countless generations are placed side by side does an entirely new manner of walking emerge. The first great turn toward humanity does not begin in the brain. These early hominins still possess small brains. They have no language that we would recognize, no mastery of fire, and no elaborate culture. The transformation begins in the base of the skull, the pelvis, the thigh, and the hesitant placing of one foot before the other. Hands do not yet fashion tools, but they need no longer bear the body's full weight at every moment. They can draw down a branch, hold food, or clasp an infant while moving. Humble capacities such as these are laying foundations for a future no living creature can imagine. Evening gathers over the open woodland. Gold light fades behind the trunks. A small band of hominins leaves the clearing and climbs towards safer ground. Below, darkness spreads through the brush, carrying the soft tread of hunters. None of these creatures knows that its body contains the opening lines of a history millions of years long. It knows only hunger, danger, and the need to survive until dawn. Yet in the higher carriage of the head, the structure of the thigh, and those few short steps between two stands of trees, a new road has begun. It is not yet the road of humankind, but for the first time, it leads in our direction. Around 4.2 million years ago, when the footprints of Ardipithecus had already receded into the deep past, East Africa continued to change with the slow breathing of the climate. Forests did not disappear, but wider spaces opened between their crowns. Dense trees still embraced the shores of ancient lakes and rivers. Beyond them stretched scrub grassland and sunlit country growing steadily drier. Within this patchwork world, a new group of hominins emerged. They remained strong enough to climb high branches, yet their legs were more clearly shaped to carry the body over the ground. Scientists call them Australopithecus anamensis, among the earliest known members of the genus Australopithecus. Seen from a distance, they would appear small, hairy, long-armed, and forward-faced. Their walk was not quite our own, but the shin and ankle reveal that. During a step, the body's weight regularly rested upon one leg, clear evidence of bipedal movement. Long forearms and capable wrists still served them well in the trees. They belonged neither wholly to the ground nor wholly to the canopy. Picture morning beside ancient Lake Turkana. Pale sky lies reflected in quiet water, and large birds feed along the shore. Among low trees, a band of Australopithecus anamensis moves slowly. One rises upright to reach a cluster of fruit. Another searches below for seeds, young leaves, and edible roots. When the group leaves the shade and crosses open ground, it travels on 2 feet. The gait may lack the ease of a modern walker, but it is no fleeting gesture. Their bodies are being organized around a new way of moving. By about 3.9 million years ago, across lands now belonging to Ethiopia, Kenya, and Tanzania, another hominin appears, Australopithecus afarensis. This species endures for almost 1 million years, many times the whole span of Homo sapiens so far. Fossils from more than 300 individuals offer not merely a skull or a solitary bone, but a broad portrait of populations once scattered across East Africa. The most famous of them was found in November 1974 at Hardar, in Ethiopia's Afar region. Under the fierce, dry sun, paleoanthropologist Donald Johansen and a colleague noticed a fragment of bone emerging from a slope. Nearby lay other pieces belonging to the same skeleton. They came from a female who had lived about 3.18 million years ago. Her scientific number is AL288-1, but the world knows her as Lucy. Roughly 40% of Lucy's skeleton was recovered, a rare completeness for remains of such age. Pelvis, leg bones, spine, ribs, arms, lower jaw, and fragments of skull allowed researchers to reconstruct how she stood and moved. Lucy was little more than 1 meter tall. Her brain was not much larger than that of a living great ape, yet her short, broad pelvis, angled thigh bones and knees show that she walked habitually upon 2 legs. The discovery overturned an attractive old assumption that the brain must have enlarged first and upright posture followed. Lucy tells the reverse story. Our distant relatives were already accomplished bipeds long before their brains approached modern human size. The earliest decisive turn toward humanity began not with exceptional intellect, but with balance, posture, and the architecture of the lower body. Lucy, however, was no miniature modern woman. Her arms remained long, her fingers and toes curved, and her shoulders retained adaptations useful for climbing. Her legs could support her full weight on the ground, while her upper body still carried her through the branches. She and her kind continued to live between two worlds. By day, they may have crossed open country in search of water, fruiting trees, and other foods. At night, tall trees could provide refuge from the predators below. A broad branch offered distance from saber-toothed cats, ancient hyenas, and other hunters moving through darkness. Fossils cannot preserve voices, memories, affections, or grief, so we cannot know the size of Lucy's group or the final events of her life. We must reconstruct daily existence cautiously from anatomy, landscape, and comparison with living primates. A day in Lucy's world may have begun when first light touched the canopy. Individuals stirred, watched the ground, and descended. Infants held tightly to their mothers, while adults remembered the direction of water and the places where food had lately been found. They ate fruit, leaves, seeds, tubers, and other plants. Insects, eggs, and small animals may have been taken when opportunity allowed. A flexible diet helped Australopithecus afarensis endure dry seasons when familiar foods failed and the band had to range farther. Bipedalism proved useful on such journeys. Upright bodies left hands free to hold food, draw down branches, and assist in carrying young. A higher viewpoint helped them see over brush and notice distant shelter or unusual movement. Yet every advantage required payment. Their small bodies were conspicuous on the ground. They possessed neither claws nor formidable teeth, and no speed could save them from every predator. Survival depended upon attention, memory, and the nearness of companions. Perhaps the band moved in an unhurried rhythm, some feeding while others raised their heads to watch at an unfamiliar sound. All might hurry toward the nearest climbable tree. Walking and climbing were not rival talents. Together, they allowed these hominins to use a greater variety of habitats. The clearest record of their steps is written not only in bone. Hundreds of kilometers south of Lucy's country, at Laetoli in modern Tanzania, a rare natural accident preserved an ancient path about 3.66 million years ago. Volcanic ash settled across the land. Light rain dampened the powder into a soft surface. Animals crossed it and left their tracks before fresh ash covered and protected them. Among those traces runs a trail nearly 27 meters long, composed of about 70 bipedal hominin footprints. They are generally attributed to Australopithecus afarensis, whose fossils occur in the same region and geological period. Let the afternoon at Laetoli return to life. Rain has passed, and the air smells of wet ash. Low cloud drifts along the high ground, while weak sunlight touches the grey earth. A hominin walks across the yielding surface. The heel comes down first. Weight passes through the sole and toward the toes. Another individual follows nearby, perhaps placing a foot partly within an earlier print. We do not know their destination. They may be heading toward water, trees, or simply away from the ash-covered ground. We do not know whether they are kin. Yet each impression shows an upright body whose two legs alternately carried its full weight. Wind and rain should have erased the marks within hours. Instead, new ash sealed them beneath the earth. Seasons passed, the volcano quietened, and the landscape altered beyond recognition, while those steps remained like a few seconds of film held within stone. Lucy gives us the anatomy of a biped. Laetoli gives us the act itself. Together they show that, more than 3 million years ago, upright walking was no longer an occasional experiment. It had become the habitual movement of at least some hominins, even while climbing remained essential. Evolutionary history, however, contains more than Lucy and her species. Africa at this time probably held several hominin populations. Some bore flatter faces, others possessed jaws and teeth adapted to particular foods. New discoveries reveal a branching tree, not a stately procession in which one species obediently replaces another. We therefore cannot be certain that Lucy is our direct ancestor. Australopithecus afarensis may stand close to the branch from which later hominins arose, or it may be a related line that ended. Lucy's importance does not depend upon making her the grandmother of humanity. Her body records a crucial stage in the making of the human gait. Dusk settles across East Africa, tree shadows lengthen, and a band of Australopithecus afarensis returns from feeding. Smaller members climb first, gripping secure branches. While adults pause to inspect the ground behind them, in the last light, their bodies remain profoundly ancient, projecting faces, small brains, and arms still at home in the canopy. Yet as they cross the final clearing before climbing to safety, they stand upon 2 feet. Their steps are not quick, and they are not exactly ours. Even so, those steps are steady enough to carry hominins across wider landscapes toward more varied food. Through an Africa that never ceases to change, millions of years later, their footprints still rest beneath volcanic ash. And Lucy can... By 3 million years ago, walking on 2 feet had become familiar across much of Africa. Small hominins still lived among riverside trees, open woodland, and expanding grasslands beneath a brilliant sky. Their bodies were not yet like ours, their brains remained small, and high branches still offered important shelter when night came. Yet another transformation had begun, quietly and almost invisibly. This time, the turning point lay not only in pelvis, knee, or foot, but in the meeting of hand, eye, memory, and stone. A natural object could be altered to serve a purpose it had never served before. Technology was entering the human story. For decades, researchers believed that the first stone tools appeared with the genus Homo. The name Homo habilis, handyman, reflected the idea that this species was among the earliest toolmakers. New discoveries have made the picture less orderly. At Lomekwi, near Lake Turkana in Kenya, archaeologists found large stones deliberately struck, battered, and fractured about 3.3 million years ago, before the clearest evidence for Homo. The maker may have been an Australopith, Kenyanthropus, or another hominin not yet identified. Lomekwian tools are heavy and rougher maker might place one stone upon a hard surface and strike it with another, or bring 2 stones forcefully together. Repeated blows produce sharp edges, perhaps accidentally at first, then with growing recognition. Imagine a misty morning beside the ancient lake. A hominin turns a weighty stone in both hands, studies its uneven faces, and brings it down upon a larger slab. The first blow leaves only a crack. The next releases a flake and reveals an edge unlike anything on the original surface. The creature does not understand mineral structure or fracture mechanics, but it sees cause and result. Fingers test the new edge, and the stone is raised again. This is not yet a master craftsman imagining a finished implement before work begins. It is nevertheless a remarkable understanding. A stone is no longer merely part of the ground. It may be used to strike, cut, crush, or open something else. By roughly 2.6 million years ago, those early experiments gave way to a more enduring tradition known as the Oldowan, named after Olduvai Gorge in Tanzania. A typical Oldowan kit contains hammerstones, battered cores, and sharp flakes removed from those cores. The pieces look simple, yet their production demands appropriate material, a useful striking angle, and enough controlled force to detach a flake without shattering the whole stone. A thin flake can cut hide and soft tissue far more effectively than hominin teeth or nails. A heavy core can break bone, crush seeds, or open a hard shell. Tools do not make the body stronger, but they enlarge the powers of hand and jaw. Hominins are no longer confined to what their natural anatomy can bite, tear, or grind. Around 2.4 million years ago, amid severe climatic and environmental change, fossils commonly assigned to Homo habilis begin to appear. The species may survive until about 1.4 million years ago. Its anatomy combines ancient Australopith features with traits usually associated with Homo. If one stood before us, we would not yet see a familiar human figure. The body is small, the arms relatively long, and climbing has not vanished from daily life. The face projects, though teeth and jaws are generally reduced compared with some earlier Australopiths. The brain is somewhat larger, but still perhaps half or less the size of ours. There is no sudden boundary at which an Australopith parent produces a recognizably human child. Late Australopiths and early Homo overlap in bewildering ways, and some fossils remain disputed. In the life of Homo habilis, however, stone tools appear to have become more regular companions. Dawn spreads through an East African valley. A group of hominins follows a riverbank, not in ranks and not toward a fixed destination. Their attention moves continually between trees, water, and the herds crossing the distant plain. Ahead, vultures circle lower. They may mark a fresh carcass, perhaps one still occupied by a powerful hunter. The hominins approach with care. They are not the grassland's strongest predators. No individual can safely confront a great cat or a clan of hyenas. Access to a carcass depends upon timing, vigilance, and immediate retreat when danger returns. Once the hunters depart, scraps of meat may cling to the bones. Small teeth struggle with thick hide and tendon, but a sharp Oldowan flake cuts through them. One individual steadies a limb while another draws stone across skin. The motion is neither quick nor elegant, yet each cut reaches food formerly inaccessible. Long bones still conceal rich marrow. A hammerstone rises and falls. After several blows, the shaft breaks, exposing the soft interior to the sun. For more than 2 million years, Oldowan tools will be used to cut, pound, crush, and reach foods such as flesh and marrow from large animals. We should not picture Homo habilis as a dedicated meat-eater or fearless hunter. Plants remain central. Fruit, young leaves, seeds, tubers, roots, insects, and small animals are taken as opportunity permits. A sharp edge processes many materials, while heavy stones open shells and crush fibrous foods. The great advantage is flexibility. When one resource disappears with the season, another can be used. A nearly stripped carcass still holds marrow. When fruit fails, buried tubers or difficult seeds may sustain the group. Tools cannot guarantee survival, but they open doors closed to many other species. Toolmaking also alters the way knowledge moves between individuals. A youngster may sit near an adult and watch how a stone is held, how a blow is directed toward a core's edge. At first, it merely knocks two stones together. With repetition, it learns that different rocks fracture differently and that only certain angles release a useful flake. We do not know how these hominins taught. Speech, if present in any form, lies beyond the reach of fossils. Observation, imitation, and practice may have been enough for a technique to pass from one creature to another and then to the next generation. A tool may be abandoned after use, but the knowledge of its making survives within the group. This is a profound shift. Until now, most advantages were built into the body and inherited through genes. Increasingly, an advantage could be inherited through learned behavior. A new generation need not wait for teeth, hands, or bones to evolve before repeating a discovery. It had only to watch, remember, and try. Homo habilis was probably not the sole maker of Oldowan tools. Other hominins shared its world: Homo rudolfensis, late Australopiths, and robust Paranthropus with massive jaws and teeth. In the Turkana Basin between 2 million and 1.5 million years ago, at least 4 different hominin forms coexisted. Evolution resembled a many-branched wood rather than a royal road leading straight toward us. Homo rudolfensis is known from fossils with broad faces, large teeth and skulls, different from those attributed to Homo habilis. Though the remains are too few for a clean division, these groups may have competed for water, food, and shelter while exploiting the landscape in different ways. Powerful jawed species could process tough plants. Early Homo increasingly relied upon dietary variety and tools that could travel with the hand. No species knew its position upon an evolutionary tree. Each inhabited only the present, rains arriving late. Rivers changing course, herds drifting across the plains. There was no promise that one branch would survive and another disappear. At evening, a band of Homo habilis may gather near large trees. Stone flakes lie beside the remnants of food. Some implements are carried away, others remain and are slowly covered by mud. Millions of years later, cores, flakes, and cut marks on animal bones allow us to recognize what occurred. Hands freed by upright walking have begun to do more than gather fruit or hold an infant. They select material, create an edge, and turn an inert thing into an extension of the body. Brains are still far smaller than ours, and the nature of any early language remains unknowable. Yet hand, eye, memory, and social learning are becoming more closely bound. The blows ringing beside Lake Turkana open another road, the road of technology, where a small discovery may be remembered, repeated, and given to generations not yet born. Near 2 million years ago, among a world of many hominin species, a new figure will emerge, longer-legged, better suited to life upon the ground, and capable of carrying inherited tool traditions across distances no ancestor has crossed. That journey lies ahead. For now, in the failing light of an ancient day, a Homo habilis sits beside the river and searches a stone for the proper point of impact. The arm rises, stone meets stone, and a sharp flake springs free. The sound lasts only a second in the immensity of the valley, but its echo will travel through millions of years of human evolution. Nearly 2 million years ago, stone still rang against stone beside the rivers and lakes of East Africa. Early members of Homo struck sharp flakes, broke bones for marrow, and followed foods that shifted with the seasons. Among the several hominin species sharing this world, however, a new figure was taking shape. It was taller, longer-legged, and no longer built for habitual life in the trees. This was a body made for the ground, for open distances, and for long journeys beneath the sun. We call it Homo erectus. Fossils generally assigned to Homo erectus appear in Africa around 1.9 million years ago. Some researchers call early African populations Homo ergaster. Others include them within Homo erectus in the broader sense. Whatever name is preferred, their proportions mark a major change. Legs are relatively long, arms shorter, and the body closer to ours than that of any earlier hominin. Where Homo habilis still carried the signature of climbing, Homo erectus became a traveler of open country. Hips, knees, and feet made walking more efficient. Long legs covered ground at lower energetic cost, and a taller, narrower body released heat while moving through the tropical day. Individuals and populations varied in stature, weight, and brain size. Yet this was the first ancient human whose proportions were unmistakably adapted to a life spent almost entirely upon the earth. One celebrated skeleton makes that body visible. KNMWT 15,000, known as Turkana Boy, belonged to an adolescent who lived near Lake Turkana around 1.6 million years ago. He possessed long legs, relatively narrow shoulders, and a height far beyond Lucy and the older Australopiths. Estimates of his age and possible adult stature differ, but the skeleton leaves no doubt that Homo erectus was equipped for sustained travel. Picture dawn beside ancient Turkana. Sunlight spreads over yellow grass while great herds move slowly toward water. A band of Homo erectus crosses the open ground. They do not constantly search for the nearest tree as their smaller ancestors did. Upright posture, long limbs, and an even stride allow them to maintain a steady pace for hours. Some carry selected stones from a distant source, another may hold food saved from an earlier meal. Adults watch the movement of predators while the young remain near the center. They have no map and no conception of the countries beyond the horizon. Yet when a spring fails, a herd turns, or a drought lengthens, the band moves a little farther. The first migration out of Africa probably happened in this manner, not as an expedition assembled to discover a new world, but as countless small expansions along rivers, lakes, and grassland corridors. Over thousands of generations, one modest movement followed another until some populations had traveled farther than any hominin before them. The clearest early fossils outside Africa come from Dmanisi in modern Georgia. Upon a natural route joining Africa, Western Asia, and the greater Eurasian continent, hominins were present there between about 1.85 and 1.77 million years ago. The Dmanisi people surprised researchers. Several were small-bodied and small-brained, and their tools were relatively simple. A very large brain and elaborate technology were not prerequisites for leaving Africa. What mattered may have been a body capable of distance, a diet flexible enough for unfamiliar habitats, and a social group cohesive enough to face them. Dmanisi is cooler than the country from which their distant forebears came. Wind crosses damp hills and dry grass. In some seasons, snow covers the mountains beyond. Ancient people searched the stony ground for carcasses, roots, berries, and every other usable food. Winter is more distinct, daylight shorter. And the animals, unlike those of tropical Africa, still. These hominins survived long enough to leave skulls, jaws, limb bones, and tools. One fossil is especially moving. It belonged to an elderly individual who had lost nearly all his teeth years before death. His jaw remodeled after long toothlessness. Perhaps others provided soft foods, shared what they had, or helped him in ways the fossil record cannot reveal. The evidence does not permit a sentimental certainty, but it allows the possibility that endurance depended upon care as well as strength. Distance alone could never ensure success. No individual could watch every danger, obtain every meal, remember every path, and protect the young alone. A group multiplied vigilance, shared rare resources, and preserved knowledge of water, roots, and materials. From the Caucasus, traces of ancient humans appear across Asia. Homo erectus, or populations closely related to it, lived in China and on Java in Indonesia at an early date. In time, their range crossed dry grassland, tropical forest, volcanic river country, and regions with cold seasons. On Java, broad rivers carried silt through fertile volcanic landscapes. The people living there stood thousands of kilometers from Africa. They could not know whether others of their kind survived elsewhere. Yet their bodies and stone tools retained the distant inheritance of their origin. This expansion was not a single victorious wave. Some groups ventured outward and vanished without descendants. Others persisted and adapted locally. Routes opened during favorable climates and closed when deserts widened, water levels changed, or habitats broke apart. Even the date of the first dispersal remains open. Dmanisi provides the earliest widely accepted hominin fossils beyond Africa. While cut marks reported on animal bones in Romania in 2025 suggest a presence in Eurasia by at least about 1.95 million years ago, without accompanying human bones, the identity of those tool users remains uncertain. As human territory widened, stone technology entered another phase. Around 1.76 million years ago in Africa, large implements worked on both faces appeared. We call them Acheulean hand axes. Their makers selected suitable stone, removed large flakes, then worked around the margins to produce a pointed end or balanced cutting edge. A hand axe was not necessarily swung like a modern axe. It could cut meat, work hide, chop vegetation, dig or break hard material. Its deepest significance lies in its making. The craftsperson had to perceive a form emerging within the raw stone and adjust each blow to approach an intended result. On a riverbank, a Homo erectus turns a dark volcanic rock in the hand. Each strike drops another flake upon the soil. The core is examined, rotated, and worked from the other face. Many attempts fail. At last, two converging edges take shape. This is more than a broken pebble. It is an object first held, however indistinctly, in the mind and only afterward completed in the hand. Acheulean technology did not appear everywhere Homo erectus lived. Denisovans people mainly used simpler tools. And many early East Asian sites lacked characteristic hand axes. Different populations carried different traditions, adapted to local stone, or solved similar problems in other ways. Human culture was already capable of variation. Fire is another innovation often associated with Homo erectus. Though caution is essential, lightning, volcanoes, and drought had created natural fires long before humans existed. Hominins could approach a recently burnt area, recover dead animals, or discover that heated foods were softer, but exploiting a natural blaze, preserving fire, and producing it deliberately are separate accomplishments. Evidence from wonderwork and swaardkrans in South Africa suggests use of fire around 1 million years ago or perhaps earlier, though the earliest record remains scattered and debated. Clearer evidence of controlled hearths comes from Gesher Benot Yaakov in Israel, about 790,000 years ago, where burnt flint, seeds, and wood cluster at repeated locations. We cannot claim that every Homo erectus group made fire or gathered nightly around a hearth. For much of early history, flame may have been a rare gift from nature, guarded anxiously because once extinguished, it could not easily be replaced. Whenever fire was maintained, darkness changed, a small blaze made an island of light, discouraged some predators, and brought warmth to cold country. Heat softened food and made it easier to process. Activity no longer ended entirely at sunset. Imagine a band seated near red embers. Beyond the light, grass shifts. Hunters move through the dark, and mountains disappear beneath the night. Within the circle, one individual restores a stone edge. A child watches an adult's hands, and food is divided into smaller pieces. We do not know whether these people possessed language in any modern sense. Gesture, gaze, repeated sound, and familiar action could nevertheless communicate danger, food, and direction. If fire kept individuals close after sunset, it also created new hours of social attention. Across hundreds of thousands of years, Homo erectus occupied a greater range than any previous hominin. Populations adapted to woodland, savanna, semi-arid country, and places with cold seasons. A study published in 2025 indicated that Homo erectus lived in a dry, semi-desert environment at Oldupai in Tanzania around 1 million years ago. Further evidence of considerable adaptability. Their success did not rest upon one invention. It arose from the union of a distance-adapted body, flexible diet, transportable stone tools, learned behavior, and increasingly important social life. Fire gradually joined that collection of advantages, though its use differed across times and populations. An ancient day closes somewhere in Eurasia. A small band stands upon a ridge and looks into a valley none of them has seen. Behind lies a chain of roots followed by generations now forgotten. Ahead, rivers, woodland, grassland, and mountains continue toward an unknown horizon. They do not know that Africa lies behind them. or that their movement has enlarged the human world from one continent into the far countries of Asia. They know only that water, food, and a tolerably safe night may lie ahead. So generation follows generation, and the first long-distance humans move onward. They carry sharp stone, memories of former springs, knowledge learned from elders, and the adaptability inherited from ancestors. For the first time, the human line is no longer confined to Africa. Hundreds of thousands of years passed after the first Homo erectus groups left Africa. Across the enormous breadth of Eurasia, ancient human populations became separated by mountains, deserts, seas, and ice sheets that advanced and withdrew. Distant bands seldom met again, through innumerable generations, each adapted to its own climate, foods, and country. From that long isolation arose several human lineages. If we could look down upon Earth 100,000 years ago, we would not see a planet occupied by a single human species. In the cold regions of Europe and Western Asia, Neanderthals tended fire in rock shelters. In the mountains of Asia, Denisovans left genetic traces that would remain unread for tens of millennia. On islands in Southeast Asia, small-bodied humans endured in worlds divided by the sea. Meanwhile, Africa held several other human populations. Among them, early Homo sapiens, human did not yet mean only one kind of being. For much of modern history, Neanderthals were portrayed as stooping, brutal, and dim. The image grew partly from 19th century interpretations of early skeletons. Old age, disease, and injury distorted some individuals, and reconstructions turned pathology into the supposed posture of an entire species. Tools, fossils, and ancient DNA have since replaced that caricature with a far richer account. Homo neanderthalensis lived from roughly 400,000 to 40,000 years ago. From Atlantic Europe, through the Mediterranean and Western Asia to the Altai Mountains of southern Siberia. They did not inhabit perpetual snow, yet many populations endured the severe climatic oscillations of the Pleistocene. Imagine a winter morning in Europe 60,000 years ago. Thin snow rests upon a hillside and among low shrubs. Cold wind moves through the valley from a partly frozen river. In the grey dawn, several figures emerge from a cave. They are shorter and more powerfully built than most modern people. Broad chests, strong shoulders, and relatively short limbs conserve heat. The skull is long and low, with a pronounced brow and a projecting middle face. A large nose may help warm and moisten cold air before it reaches the lungs. These are not marks of an inferior body, but of hundreds of thousands of years lived in demanding country. Neanderthal brains averaged about the size of ours and were sometimes larger. Though size alone cannot reveal the nature of thought, more eloquent evidence lies in their hunting, fire use, tools, and the survival of gravely injured companions. A hunting party leaves early with wooden spears and carefully prepared stone points. It follows reindeer, bison, wild horses, or other large game across mud, snow, and dry grass. Success is never assured. Close approach exposes hunters to horns, hooves, and crushing weight. Neanderthal bones often carry fractures, head injuries, and other serious wounds that healed long before death. Some individuals therefore lived for years after accidents that would have made feeding or travel difficult. Suggesting support from companions, Shanidar Cave, in the Kurdish region of modern Iraq, preserved several Neanderthal skeletons, one elderly man. Shanidar I survived injuries to the head, arm, and leg and reached a relatively advanced age. We cannot name those who aided him or know precisely what they did. Yet it is difficult to explain such survival by solitary strength. Within a shelter, stone edges divided food into manageable portions. Hides were cleaned and worked for covering bodies or bedding. Mousterian toolmakers often prepared a stone core in advance, arranging its surfaces so that a later blow removed a flake of approximately intended form. This required more than reacting to the present face of a stone. The maker anticipated stages not yet visible, controlled angle and force, and knew when to stop. Such technology speaks of planning, dexterity, and skills transmitted over generations. The Neanderthals were not uniform consumers of big game meat. Teeth, residues, bones, and sites show diets shaped by place and season. Some groups relied heavily on flesh, fat, and marrow. Others in warmer or coastal regions used plants, nuts, small animals, and aquatic foods. A woodland community in Europe could lead a life very different from one near the Mediterranean or upon the steppe of Western Asia. At night, fire organized the shelter. Light moved across stone walls. Figures shifted in the draft from the entrance. Tools were repaired. Food warmed near embers, and children watched the gestures they would one day repeat. We cannot recover Neanderthal speech. Anatomy, genes, and complex social life indicate the capacity for sophisticated vocal communication. But fossils preserve no sentence. It is therefore as unjustified to make them speak exactly as we do as it is to reduce them to crude noises. Their symbolic world is equally difficult to reconstruct. At some sites, Neanderthals used mineral pigments and collected shells, raptor claws, or other objects without an obvious practical purpose. Certain pieces were polished, incised, or arranged in ways that may relate to ornaments and symbols. Their meanings died with their makers. Evidence for deliberate burial is also debated. Some bodies occur in pits and positions suggesting purposeful placement, though not every case is clear. And burial need not imply belief in an afterlife. What we may say is that some Neanderthal dead were treated differently from animal remains, perhaps through attachment, memory, or a particular response to loss. While Neanderthals occupied Europe and Western and Central Asia, another ancient people lived farther east. For most of history, no one knew they had existed. They left no nearly complete skeleton and no securely reconstructed face. The name Denisovan arose from a minute discovery in Denisova Cave in Siberia's Altai Mountains. In 2008, archaeologists recovered a fragment of finger bone from a young individual. Its shape offered little clue, but ancient DNA survived inside. Genome analysis showed that the owner was neither Neanderthal nor Homo sapiens. She belonged to a separate lineage, closely related to Neanderthals, but divided from them in the distant past. The people were named after the cave. It was like finding an unknown room within the house of human history. A sliver of bone revealed an entire population whose range had extended across a considerable part of Asia. Denisova Cave did not belong to one species. DNA from its sediments indicates Denisovan presence from about 250,000 years ago, with Neanderthals occupying the cave during later periods. Over tens of thousands of years, different groups arrived, departed, and returned. Picture the entrance on a cold afternoon. Forest and steppe descend into the valley. Snow lies on distant slopes. Wind crosses the mouth of the cave. A Denisovan group sits near fire. Though we cannot confidently give them faces, their surviving record consists chiefly of teeth, a few bones, and genetic traces embedded in soil. Yet DNA can recount meetings that anatomy alone cannot. Around 90,000 years ago, a girl lived in this region. A small fragment of her bone, known as Denisova 11, showed that her mother was Neanderthal and her father Denisovan. Her existence proves more than geographic overlap. The lineages met and had children. Her Denisovan father also carried more distant Neanderthal ancestry, indicating that such unions occurred on more than one occasion. The boundaries between ancient human branches were not sealed walls. Populations differed in body, history, and range, yet some encounters produced descendants later when Homo sapiens expanded beyond Africa. Our species also met the ancient humans of Eurasia. Many living people retain Neanderthal-derived DNA. Communities in Asia and especially Oceania carry notable Denisovan ancestry. Some inherited variants influenced immunity, metabolism, and adaptation. A celebrated example is a gene variant helping Tibetan populations live at high altitude, derived from a population related to Denisovans. Neanderthals and Denisovans were not the only humans sharing the Earth. Deep inside the Rising Star cave system in southern Africa, researchers found more than 1,000 bones belonging to Homo naledi. Its anatomy combines features that seem to come from very different ages. Feet and parts of the hands resemble ours, shoulders, chest, pelvis, and a small brain recall much older hominins. The astonishing element is time. The remains date to roughly 335,000 to 236,000 years ago, overlapping the early history of Homo sapiens. Because many bodies lay in remote chambers, some researchers propose that Homo naledi deliberately placed its dead there. Claims of intentional burial and markings remain under scientific review. We should not turn open questions into settled ritual. The secure mystery is that numerous bodies reached spaces extraordinarily difficult to enter. Farther east, the sea-enclosed evolutionary worlds of another kind. On Flores in Indonesia, Homo floresiensis, often called the Hobbit, stood little more than a meter tall and survived until surprisingly recent times. Remains from Liang Bua cave date broadly from about 100,000 to 60,000 years ago, while possibly associated tools persist to around 50,000 years ago. Older, smaller fossils on Flores show that ancestors of these little humans had occupied the island by at least 700,000 years ago. A small body and brain did not prevent long-lived stone technology. Once again, brain size alone proves a poor measure of behavior. On an island with limited food, smaller bodies require less energy. Over generations of isolation, populations may shrink, as many island animals have done. The origin of Homo floresiensis remains disputed. It may descend from Homo erectus, reduced by island evolution, or from an older human branch that left Africa much earlier, north of Flores, on Luzon in the Philippines. Another small-bodied lineage left teeth and bones in Callao Cave. Named Homo luzonensis in 2019, the initially described remains are at least about 50,000 to 67,000 years old and combine archaic traits with characteristics of Homo. Neither Flores nor Luzon was fully joined to the mainland even during low sea levels. Ancestors reaching those islands crossed open water somehow, perhaps deliberately, perhaps upon natural rafts or storm-torn vegetation. The evidence does not reveal their intention. These communities did not know they inhabited isolated experiments in human evolution. On Flores, small people moved through tropical forest for plants, small animals, and river foods, thousands of kilometers away. Denisovans adapted to high plateau and cold mountains farther west. Neanderthals crossed European valleys under winter skies. None knew the full company of human species upon the planet. This age was not a simple contest in which inferior creatures queued to be replaced by a superior one. Each lineage endured because it fitted its world. Neanderthals survived repeated glacial cycles. Homo floresiensis persisted for ages upon a distant island. Denisovan ancestry traveled from Siberian cold into the forebears of communities near the tropics. Between about 70 and 40,000 years ago, the balance began to alter. Homo sapiens expanded beyond Africa into lands already inhabited. Our ancestors met Neanderthals, Denisovans, and probably populations science has never named. Some meetings produced children. Others may have involved competition for water, food, shelter, or territory. There is no evidence for one great war that erased every other humanity. Their disappearance probably arose from many forces acting together. Small population sizes, unstable climate, competition, disease, reduced genetic diversity, and absorption into larger groups. For Neanderthals, environmental change, demographic disadvantage, and long genetic assimilation all remain active explanations. By around 40,000 years ago, the last clear Neanderthal traces fade. Denisovans no longer persist as a population identifiable to us. Small island humans vanish from the fossil record during the broader expansion of Homo sapiens.
Yet none disappeared entirely. Neanderthal sequences survive in many people whose ancestry lies outside Africa. Denisovan sequences endure especially in parts of Asia and Oceania. DNA became a biological memory of encounters in valleys, caves, and forgotten countries. Imagine an evening 50,000 years ago upon cold ground in Western Asia. A group stands on a hillside and sees another fire below. It is not lightning or a wandering grass fire. Around it move people whose bodies and faces differ slightly, yet who also shape stone, guard children, and gather when darkness falls. Neither group possesses the names Neanderthal, Denisovan, or Homo sapiens. They see beings at once strange and familiar: watchful eyes, expressive bodies, hands capable of keeping flame. For a moment, branches of the human family stand close together. Some people will leave and never meet again. Some may compete. Some will approach. And descendants will carry the histories of both lines. Earth is still a planet of many humanities. In Africa, meanwhile, another branch is forming wider networks and beginning to expand. Its members are not stronger than every other human, nor yet numerous enough to be certain of survival. Their growing capacity for cooperation, the exchange of knowledge, and adaptation to varied environments will nevertheless carry them to every habitable continent. They are Homo sapiens. In the next chapter, we enter the journey of the last human species left alive. Around 300,000 years ago, Africa remained a vast continent of landscapes in continual motion. In the north, dry country alternated with lakes and grasslands whenever the climate entered a wetter phase. In the east, deep valleys, volcanic highlands, and great lakes occupied the broken ground of the rift far to the south. Open woods, savanna, and long coasts lay beneath cold winds from the ocean. Across these widely separated regions lived many ancient human populations. They did not form a single people, speak one language, or even know that most of the other communities existed. Some lived near coasts, gathering shellfish left in shallow pools by the tide. Others followed herds inland, dependent upon rivers, lakes, and rains that came without certainty. Within this immense, shifting network, our own species began to take form. We call ourselves Homo sapiens. Yet there was no particular morning when a fully modern child was born to parents who still belonged to another species. Evolution draws no boundary as clean as the chapter heading in a book. Traits arose in different populations, traveled when people met, and sometimes disappeared when communities became isolated or declined. The fossils of Jebel Irhoud in Morocco, about 315,000 years old, preserve one of the earliest known stages of Homo sapiens. Their faces and jaws already possess many relatively modern features, while the rear of the skull remains long and more archaic than the rounded braincase of people today. These were not complete modern humans suddenly appearing at one appointed place. Their bodies were mosaics in which old and new lived together. Imagine Jebel Irhoud late in the day. North African sunlight fades over the ground. A small community sits near shelter amid flint that has been heated and struck into tools. Seen from the front, their faces might seem far more familiar than those of earlier humans. Consider the skull and the full history of the body, however, and we are looking at an early transitional population. No one there knows that burnt stones and fragments of bone will one day help remote descendants recognize their own deep origin. Other fossils, from Omo Kibish and Herto in Ethiopia, Florisbad in South Africa, and sites across the continent, show that the making of Homo sapiens cannot be reduced to one point on a map. Genetic models likewise suggest that the ancestors of living people belonged to African populations that were partly divided, yet continued exchanging genes across hundreds of thousands of years. Our beginning resembles a network of branching and rejoining rivers. Not one stream issuing from a single valley, climate repeatedly opened and closed the channels of that network. When rain returned, deserts became grassland, lakes formed, and green corridors joined regions long separated. People followed animals, sought new water, and encountered unfamiliar groups. When aridity returned, those corridors closed and populations withdrew into ecological refuges. Every meeting might carry stone, skills, partners, stories, and new solutions. Every separation allowed local traditions and bodily traits to follow their own paths. Through that long rhythm of contact and isolation, the characteristics of Homo sapiens assembled. Our bodies became lighter than those of many other ancient humans. The skull grew higher and rounder, the face tucked beneath the forehead, and a distinct chin appeared. Yet the later success of Homo sapiens cannot be explained by bone shape or brain size alone. A greater advantage may have lain in the way brains became connected through teaching, imitation, communication, and wide social networks. Across African caves and shelters, traces of an increasingly elaborate inner and social world began to appear. Ochre was ground, mixed, and carried far from its source. Small shells were pierced so they could be strung. Intentional lines appeared upon bone, stone, and ostrich eggshell. Such things did more than cut meat, break bone, or warm the body. They may have conveyed identity, relationship, memory, or belonging. There was no single cognitive revolution ignited within one generation. Mineral pigment had been used by hominins much earlier, while clearer symbolic practices emerged in different places at different times. Modern culture was probably built gradually through invention, loss, and rediscovery, not delivered complete in one miraculous moment. Picture a person sitting near a cave entrance in southern Africa about 100,000 years ago. Before them lie red ochre, a grinding stone, and a small shell. The ochre is scraped to powder, combined with other materials, and stored in a natural container. We cannot know whether the red mixture decorated skin, prepared hides, preserved material, or served several purposes. The sequence nevertheless required preparation, remembered proportions, and a plan of several stages. An idea remained in the mind long enough to become an object in the world. Elsewhere, shells of similar size and form are chosen and pierced, perhaps to be arranged upon a cord. An ornament does not make its wearer faster or safer from a lion. It can. However, say what a hunting tool cannot: who this person is, where they belong, what position they hold, or whose memory they carry. Shared symbols let people who were not close relatives recognize one another, exchange goods, and cooperate. Community no longer meant only the individuals seated around one fire. It could extend across a broad network linking many bands over long paths. Such networks may have carried Homo sapiens through severe times. If one group lost access to fine stone, another could supply it. If game vanished, knowledge of a coast, edible plants, or a route to water might travel through meetings. When numbers fell, relationships with neighbors widened the choice of partners and reduced the danger of isolation. The strength of the network did not belong to one heroic individual. It lay between people more than 100,000 years ago. Some Homo sapiens populations began moving beyond Africa. Fossils and tools in the Levant record early expansions long before the dispersal that gave rise to most ancestry outside Africa today. Certain groups entered Western Asia during favorable climates, remained for a time, then disappeared or left few descendants. The departure from Africa was therefore not one procession, but repeated advances, retreats, failures,
and beginnings. Between roughly 70 and 60,000 years ago, a more consequential expansion carried populations through northeastern Africa and Western Asia. Even then, people did not immediately pour across Eurasia. Genetic and archaeological studies suggest that some groups may have remained in Western Asia or around the Iranian plateau for many millennia before descendant branches spread more rapidly east and west around 45 to 50,000 years ago. No traveler understood that they were leaving the continent in which their species had formed. They followed rivers, animal tracks, and rain. Each generation knew only a modest territory. A child might be born a few days' walk from the country of a grandparent. Yet over thousands of generations, such small displacements joined into a continental journey. At midday, a band rests beneath rock. Adults search for water, mend tools, and watch the sky, while children learn by touching everything near them. When the heat softens, they move toward a valley none of them has seen, beyond Africa. They enter lands already inhabited by other humans. In Western Asia and Europe, Homo sapiens met Neanderthals. Farther east, they met Denisovans and perhaps archaic populations from which science has found no fossil. The encounters did not lead only to avoidance or competition. DNA proves that people from these lineages had children whose own descendants were fertile. Ancient genomes published in recent years indicate that the common ancestors of most living people outside Africa acquired Neanderthal DNA during a period around 45 to 49,000 years ago. Certain individuals who lived near that time had a Neanderthal ancestor only a handful of generations back. The meetings were repeated and intimate, not an abstract brush between two distant categories. In a cold valley, a Homo sapiens band may see smoke rising from a Neanderthal shelter. Bodies, faces, and evolutionary histories differ, but both groups know the meaning of fire kept through the night. Both understand the cry of a child, the sudden silence of danger, and the value of food during winter. There may have been conflict, there may also have been avoidance, exchange, shared territory, or temporary alliance, in at least some cases. People drew close enough to form families. As Homo sapiens passed through southern and southeastern Asia, encounters with Denisovans likewise entered our genome. Archaic variants may later have aided adaptation to disease, altitude, and unfamiliar environments. Our success is therefore not a pure story of replacing every other human. It is also a story of receiving and carrying part of their inheritance. From Southeast Asia, people reached a frontier unlike any their species had faced: open sea. Even when sea levels were low, the islands of Wallacea were divided by deep straits. Reaching Sahul, the joined landmass of Australia and New Guinea, required crossing water that could not be walked. Ocean current models suggest that successful settlement is unlikely to have resulted only from a few accidental castaways. By at least 50,000 years ago, humans could organize voyages lasting several days. Archaeological evidence may place them in northern Australia by about 65,000 years ago, although the exact date remains under study. Imagine a shoreline at dawn. There is no land path ahead, no animal trail, no line of trees leading to the next spring. There is only a level horizon of water and, beyond it, islands, faint as clouds. Such a crossing demands more than the courage of one person. A community must gather floating material, carry water, protect children, and coordinate movement in one direction. Seabirds, clouds, swells, or distant smoke may offer guidance. But no traveler can be certain what waits beyond sight. When new land rises slowly from the water, people have achieved something no earlier human is securely known to have accomplished on such a scale. They have not merely adapted to landscapes. Through planning and cooperation, they have crossed the empty space between them. Consider what these journeys looked like at human scale. There was no arrow drawn across a continent and no leader promising a destination.
There was a morning when a familiar spring had failed, an afternoon when scouts found tracks beyond the usual hills, a season when families chose to remain near new water instead of returning. A generation learned one valley, its children learned the next. Distance accumulated almost invisibly. One evening, perhaps 48,000 years ago, a traveling group settles near the mouth of a river in southern Asia. Elders know the country behind them through memory, while the country ahead is known only through birds, smoke, currents, and stories exchanged with strangers. Stone from one region lies beside shell from another, evidence that objects and information have passed through many hands. A child watches someone bind a point to a shaft. The lesson is not delivered as an abstract lecture, it is repeated through gesture, correction, failure, patience, and the shared attention of learner and maker. Farther inland, another community waits near a narrow animal path. Their knowledge of this place is exquisite. Which wind will betray human scent, where wounded game will turn, which roots can be eaten after careful preparation, and which cloud over distant high ground announces rain. Intelligence here is not a number hidden within one skull. It is an arrangement of people, tools, seasons, remembered places, and trust. When groups meet, the moment may be tense. Strangers carry unfamiliar voices and ornaments, and approach may risk violence. Yet meeting also offers material unavailable locally. News of water, recognition of kin, and partners beyond a small band. A bead, pigment pattern, or manner of dress can make identity visible before every relationship is explained. Symbol and language allow cooperation to stretch past immediate family. Such connection does not make Homo sapiens invulnerable. Entire communities vanish. Voyages fail. Droughts trap people. Epidemics pass through camps, and innovations are forgotten. The archaeological record is full of beginnings that left little future. The important difference is statistical rather than heroic. Wider, more frequently renewed networks give knowledge more routes by which to survive. The sea crossing into Sahul reveals this social power with unusual clarity. A raft or other watercraft cannot be improvised at the last second by one frightened castaway if settlement is to succeed. Materials must be gathered and joined, water and food allocated, people of different ages kept together, departure timed, direction maintained, and enough women and men reach the new land to establish a lasting population. We do not know the vessels or commands they used. We know the result: human communities appeared beyond deep water barriers. At sea, the familiar earth sinks behind them. Children hear water against the craft through the night. Adults watch the same stars that had shone above African ancestors, but now those stars hang over an undertaking no one present can be certain will end safely. At dawn, cloud accumulates in one part of the horizon. Birds travel with purpose. Eventually, a dark line separates itself from the sky. The sight of land is not merely relief. It is proof that coordinated imagination has carried people across a place where no footprint can remain. On the new shore, however, the challenge begins again. Travelers must identify water, shelter, dangerous animals, edible plants, and workable stone. Imported knowledge is tested against an ecosystem for which no inherited story is entirely sufficient. Observation and experimentation create a local culture. Children born there will regard as ordinary what terrified the first arrivals. This pattern repeats through the human expansion. Inherited skill meets unfamiliar ground. Some practices fail, others are modified, discoveries become tradition. Culture is neither a fixed possession nor a ladder on which one population permanently stands above another. It is a living storehouse, vulnerable when communities fragment, and powerful when people remain connected. During the tens of thousands of years that followed, Homo sapiens entered rainforest, desert, high plateau, frozen steppe, and distant coast. Each demanded a different education. No single toolkit could answer every environment. So technology and subsistence changed continually. In cold country, people needed fitted coverings, windbreaks, dependable fuel, and knowledge of migrating herds. They learned when animals would pass, where snow concealed danger, and how stone, bone, antler, sinew, and hide could be combined. A point fixed to a shaft could be replaced without discarding the whole weapon. A needle could turn skins into clothing rather than a loose covering. Storage could carry food from a successful week into a poor one. In tropical forests, survival required another library of knowledge. Hundreds of plants, the habits of small animals, seasonal fruit, concealed water, poisonous species, and paths almost erased by growth. On coasts, people read tides, gathered shellfish, trapped or caught fish, and learned that the same shore changed hour by hour. On high plateau, biology and culture together faced thin air, dispersed resources, severe nights, and long winters. Human adaptability did not mean an individual could arrive anywhere and immediately thrive. It meant communities could observe, remember, experiment, and pass a local way of life to their children. By the end of the Pleistocene, people also entered the Americas, the last great continental lands without Homo sapiens. Routes, dates, and the number of migrations remain active questions. Archaeology and ancient DNA show a history more complex than one band moving through one corridor. Coastal and interior pathways may have opened at different times. Populations divided, met again, and expanded rapidly, adapting from Alaska to the far south of South America. Within a relatively brief portion of evolutionary time, descendants of African populations occupied almost every habitable region of Earth. What made Homo sapiens the last surviving human species? There is no evidence for a single answer, and every simple answer distorts the people who shared our world. We cannot merely say that Homo sapiens was more intelligent. Neanderthals made complex tools, controlled fire, planned hunts, used pigments, and supported injured companions. We cannot say that our bodies were always stronger. Neanderthals were usually far more robust, nor did art, ornament, or symbolic behavior belong exclusively to us. Other hominins possessed complex traditions of their own. The advantage may have been a combination of many small differences, none decisive in isolation. Wide social networks allowed materials and information to travel over greater distances. Increasingly flexible language may have helped people coordinate, describe absent places, explain sequences, negotiate alliances, and teach tasks whose essential stages could not all be demonstrated at once. Language also allowed memories to be rearranged into warnings and plans. The flood that came during a grandparent's youth, the valley beyond a ridge, the behavior of an animal not presently visible, or the obligations linking one group to another. Culture became cumulative. A discovery did not necessarily vanish when its inventor died. A child could learn an established method, add one modest improvement, and pass both onward. The community's knowledge gradually became greater than the knowledge of any single person. No one individual needed to understand every plant, root, stone source, hunting practice, kinship link, and seasonal sign. Knowledge could be distributed among many minds and summoned through cooperation. Population size may have mattered as much as individual ability. A small, isolated band can lose a rare skill when its only practitioner dies. A larger population in regular contact with neighbors has more opportunities to retain techniques, compare solutions, and recover after local disaster. Networks provide partners when numbers fall, refuge when a habitat fails, and alternative food when familiar resources disappear. They also permit specialization. One person becomes particularly skilled at stone, another at hides, another at remembering routes or interpreting weather, while all benefit from the exchange. Many archaic human populations, by contrast, remained small and scattered. This does not mean they were poorly adapted. They had survived for hundreds of thousands of years. Yet a succession of harsh seasons, low birth rates, disease, or broken contact with neighboring bands could push numbers below recovery when Homo sapiens entered their territories. Even modest competition, or repeated interbreeding with a more numerous population, could gradually dissolve the genetic distinctiveness of the smaller group. One demographic model proposes that continued mixing between incoming Homo sapiens and less numerous Neanderthal communities could replace much of the separate Neanderthal gene pool across many millennia without any rapid extermination. It is only one hypothesis among several alongside climate instability, disease, competition, and population decline. The real history probably differed from valley to valley and century to century. In one region, drought may have emptied the land. In another, a small community may have joined newcomers. Elsewhere, competition may have been bitter. History rarely requires one mechanism to operate everywhere. The survival of one human species therefore does not mean that all others were simply erased. Part of them entered us. Neanderthal and Denisovan DNA persists in many living bodies. These sequences do not make their carriers less Homo sapiens, but they remind us that the human tree did more than branch. Branches separated, met again, and continued within the same descendants. Around 40,000 years ago, the hearths of other human populations began to disappear from the visible archaeological record. Neanderthals were no longer recognizable as a separate people. Denisovans withdrew beyond the reach of identifiable bones and sedimentary DNA. On distant islands, small human lineages ceased to leave new tools and remains. Earth gradually came to hold only one human species. No one alive then could have known it. A Homo sapiens band seated beside fire on a cold night cared about the next dawn, not the global fate of a genus. They repaired spear points, divided food, checked the wind, and drew coverings around sleeping children. Beyond the light, grass moved as it had moved for millions of years. These people did not think of themselves as victors in an evolutionary contest. There may never have been a contest with agreed rules, or a destination. They were simply the people who remained alive. Descendants continued outward. Much later they built settled villages, domesticated plants and animals, raised cities, developed writing, and attempted to read traces buried beneath the earth. Hands once occupied with a stone core learned to shape metal, grind lenses for telescopes, sequence genomes, and hold a fragile piece of bone hundreds of thousands of years old. Yet evolution did not end when cities appeared. Bodies continued responding to climate, diet, altitude, pathogens, and the social environments people themselves created. Culture changed still faster, continually remaking the world to which humans then had to adapt. Farming altered teeth, skeletons, disease, work, and population. Dense settlements created epidemics impossible for small, wandering bands. New foods rewarded genetic variants that had once mattered little. Technology reduced certain dangers while inventing others. Our species has never stepped outside nature, nor are we the goal toward which evolution had always been traveling. Homo sapiens is the only living branch of a tree that was once crowded. Its survival does not make earlier branches failed drafts. Each was a complete population shaped to a world of its own, carrying children, knowledge, fear, memory, and ways of making a life. Look back across the whole journey. A small hominin holds its body upright in an African woodland, and 2 feet begin to carry ancestors farther. Freed hands turn stone into a tool. Homo erectus leaves the original continent and brings learned skills into unfamiliar country. Neanderthals, Denisovans, and other humans construct their own lives in caves, cold forests, plateaus, coasts, and isolated islands. At last, Homo sapiens appears, not as perfection descending upon the earth, but as one more branch among many. What allowed that branch to continue may have lain less in the strength of an individual than in the ability to connect minds. Humans share food, teach skills, create common symbols, maintain obligations across distance, and cooperate with people they have never met. Each person remains physically vulnerable, placed beside the accumulated memory of generations. However, a community can accomplish what no solitary mind could conceive. 7 million years did not produce us according to a plan. Evolution generated alternatives, experiments, adaptations, meetings, and paths that ended. We are alive because one branch passed through enough changes, joined enough communities, and preserved enough knowledge to continue. That history remains present within the quiet architecture of the body. It is in the foot that carries weight through a stride, the hand capable of a precise grip, the eye drawn immediately to a familiar face, the infant's demand for attention, and the comfort human beings still seek in sitting close to others after dark. It is present in our dependence upon teaching, our distress in isolation, and our habit of turning experience into a story another person can remember. We are the last surviving human species, yet bone, genes, tools, and inherited stories show that we have never truly traveled alone. The traces by which we recover this history are themselves uneven. A cave may preserve a tooth, while an open camp leaves only scattered stone. DNA survives in some cold sediments and disappears completely in warm, wet soil. Absence of evidence, therefore, does not always mean absence of people. Every new fossil or genome can redraw a route once thought secure. The story must remain confident where several lines of evidence meet and modest where they do not. That modesty changes the meaning of survival. We need not imagine Homo sapiens marching inevitably toward dominion. For most of our existence, numbers were small, childhood dangerous, food uncertain, and knowledge dependent upon fragile human relationships. A lost route, a broken alliance, or several years without rain could erase generations of skill. Survival came through repeated acts of attention. Someone remembered a spring, someone shared meat, someone showed a child how stone should break, someone welcomed outsiders closely enough for new families to form. The last fires of other humans did not all go dark. 7 million years have passed since those first uncertain steps upon African ground. Across a span almost beyond imagination, many human species arose, adapted, traveled, encountered one another, and quietly disappeared. Some left only a few fragments of bone sleeping beneath stone and earth. Others still live within us, carried forward in the Neanderthal and Denisovan sequences of our DNA. Our journey pauses in the modern world, where descendants of people who once feared the darkness can examine fossils, read genetic maps, and recover something of their own beginning. Evolution, however, has never truly ended. It continues through every generation, in adaptation, in learning, and in the memories entrusted from one human being to another. Thank you for remaining with the story to its close. If tonight's narration has helped you rest, you may subscribe to the channel and follow the page for the journeys still to come. Would you next like to enter the daily world of the Neanderthals? Follow Homo sapiens beyond Africa, or explore the mysteries of vanished human species? Leave your choice for the next story. Until then, may the night be peaceful, and may your sleep be deep